The next problem is find the equivalent resistance. So here we have the circuit. We're having the 5 resistors. Each resistor is having resistance 5 ohm. This is the resistance is having 5 ohm. This one is also 5 ohm. This one, and all these three. All the resistances are having the resistance 5 ohm. Now, in order to find out the equivalent resistance, now look at this one. We have the point A and B here. Okay. Now here is the cell. Now the current I is flowing through the resistor 5 ohm. Now the current reaches at the point here. Now it has two paths. It has two paths. Okay. It has the two paths to flow. Now let's suppose that the current I is divided here. Okay. Now here, whatever the current is flowing through the resistor 5 ohm, this one and this one resistor, it is I1 only. How? Because if you have considered these 2 points, the amount of current flowing through these 2 resistors will be same, which means these 2 resistors are in series combination. Got the point? Here 5 ohm and 5 ohm are in series. This implies that R equivalent is equal to R1 plus R2. This is equal to 5 plus 5 is equal to 10 ohm. We got the R equivalent for these 2 resistors is 10 ohm. Now after that we need to redraw the circuit. So let's redraw the circuit. Redraw the circuit. Here the resistance, this 5 ohm I will keep as it is. Okay. And here, and whatever these 2 resistors are there, I will keep as it is. Okay. And this one resistance also I will keep as it is. So here it is 5 ohm, here also it is 5 ohm, and this cell, electric cell as it is. Okay. Now in place of these 2 resistors we got the equivalent resistance which is having the resistance 10 ohm. So I will connect that one 10 ohm resistance here. Okay. Fine. So it is having the resistance 10 ohm. Okay. Right. Now look at the circuit diagram now. Now these 2 resistors are in parallel. How? Look at here. Current I is flowing from the battery, positive terminal of the battery. Current passes. When it will reaches at this one point, it has the 2 path. Okay, it has two paths. Let's suppose that the current I1 and here is I2. And again, when it will reaches at the point here, this will be again I, which means these two resistors are in parallel. Here 10 ohm and this one 5 ohm resistors are in parallel. So this implies that the R equivalent is equal to R1 into R2 divided by R1 plus R2. This is the formula to calculate the equivalent resistance when we have the resistances only 2. Okay, now this is equal to R1 it is 10, R2 it is 5. So 10 plus 5, this is equal to 10 into 5, it is 50. 10 plus 5, it is 15. 15 ones are 15. 15 3s are 45. So put 1 point, take 0. Again it is 50. You will get again 3. Therefore, R equivalent is equal to 3.3 ohm. Okay. Now this is the equivalent resistance for these two resistance. Now again what we need to do? We need to redraw the circuit. Redraw the circuit. Okay. So here the resistance 3.3 ohm. In place of these two, the equivalent resistance we have 3.3, and these two remaining I will keep as it is. Okay. So here it is 5 ohm and it is also 5 ohm, and we have the battery, that is the cell. Okay, and these are the point A and B. Now you see the circuit. Now all these three resistors are in series combination. Okay, between the point A and B, the resistors are connected one end after another. It means they are connected in series. Here 3.3 ohm, 5 ohm and 5 ohm are in series. Therefore, R equivalent is equal to R1 plus R2 plus R3. This is equal to R1 it is 5, R1 3.3, you can take anything. Okay, 3.3, R2 it is 5, R3 it is 5. Now add all these three, it is 13.3 ohm. So R equivalent is 13.3 ohm, which means that in between these 2 points, a single resistance, that is the equivalent resistance, we can connect, which is having the resistance 13.3. Okay, got the right. So hence we have solved the problem.
Okay.
The next question is, in a given circuit, calculate the following. It is the given circuit. cell plug key, and we have in between the point A and B, we have the 3 resistors. First one is having 5 ohm resistance, second one is having 10 ohm resistance, and third one is having 30 ohm resistance. So first question, the sub question is calculate the value of current through each resistor. Calculate the value of current through each resistor. Okay, now let's suppose that when the switch is on, the current I is flowing in the circuit. When the current I reaches at the point A, you know that when in between point A and B, there are 3 resistors are connected, and these 3 resistors are in parallel combination. Okay, now as these 3 resistors are in parallel, which means the current flowing through the each resistor is different. So here let's suppose that the current flowing through the resistor 5 ohm is I1, 10 ohm is I2, 30 ohm is I3. Got the point? So here we need to calculate the value of current through each resistor. Okay, so first I will calculate this one by Ohm's law. By Ohm's law. By Ohm's law, I1 is equal to V divided by R1. Let us suppose that it is having the potential difference V. According to Ohm's law, this is equal to V is equal to, so here we need to be calculate the value for V. Here we have the value for the V.
Okay.
So here we have potential difference is 6 volt. Therefore V is 6, R1 is 5. This is equal to 5 ones are 5 ones are, take the point, take 0, 5, it will become 10. So 5 twos are 10. Therefore I1 is 1.2 ampere. I1 is 1.2 ampere. Similarly, I2 is equal to, according to Ohm's law, I2 is equal to V divided by R2. This is equal to V is 6 volt, R2 is, it is 10. This is equal to, so in order to remove the denominator 0, I need to be put the point in the numerator. So I can write directly, it is 0.6 ampere. Okay. Now similarly for the I3 is equal to V divided by R3. V is 6, R3 is 30. So take 1 0. So 31s are 32s are. Okay. So here it is 0.2 ampere. So I got I3 is equal to 0.2 ampere. So we have calculated here current through each resistor. Now come to the question, second one, total equivalent resistance. Second one, the total equivalent resistance. As these are connected in parallel, the total equivalent resistance 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay. Now this is equal to 1 divided by R1 is 5, R2 is 10, R3 is 30. This is equal to, take the LCM. The LCM is, it is 30. Okay, it is 30. Now 5 6 are 30. Okay, now this will be 5 10 3 are, okay, and this is 1. Now this is equal to 10 divided by 30. Here in LHS side we have 1 by R equivalent. Therefore, R equivalent is equal to 30 divided by 10. What I have done? Just I have taken reverse. So this 0, both are get cancels together. So I can write R equivalent is equal to 3 ohm. 3 ohm. Okay, R equivalent is equal to 3 ohm. Now, third one, total current in the circuit. By Ohm's law. By Ohm's law. Now apply the Ohm's law to the whole circuit. Apply the Ohm's law to the whole circuit. V is equal to I into R. Okay. Therefore, I is equal to, I can write V divided by R. This is equal to V, it is 6, R, it is 3, because we are taking the equivalent resistance. Okay, now 3 ones are 3 twos are. This is equal to 2 ohm. So here, sorry, it is 2 ampere. So here the current flowing through the circuit is 2 ampere. So hence we have solved the problem.